All right, and I'm going to start over here. So this is exponents. Number 4. And most of you have this in your notebook already. You have it in your composition book. This one's entitled Multiplying Polynomials. All right, so let's do some quick review. If we have x to the power 2, what's a name for the power 2? If you had to talk about the power on the x, what's a name you could call it? What's one? There's a couple. What could you call it? Anyone? What do you say? Throw it out there. Well, so I've been calling it a power already, all right? So you can call this a power. Any other name? You can also call this an exponent. What do you call this part? What's the x called? What's the x portion of the x squared? Do you know that one? Anybody know that name? No? Okay, review. So this one's called a base. Right, so you have a base and a power. You could call the power an exponent. You could say it's an exponent 2 or an exponent squared or power 2, that kind of thing. The other complication is you can call this whole thing all together. You can call this an exponent. So I kind of prefer to call it a power so that so I call the whole thing maybe an exponent, or I call this an exponent, but I call that a power separately and a base. Okay, you okay with the vocabulary at least? Okay. So if there's only a single term like this, what do you call a single term? What do you call a single term? Yes. A single term is called monomial. Say monomial. Everybody together, say monomial. Okay, good. Thank you. So, and do you see this? Hence the one term. You okay with this? Now, if it starts to expand, let's say we had in parentheses here, we had an x plus 2. Now how many terms?
2.
Therefore, what do you think you call it? Okay, everybody say binomial. Nice, right? Bicycle. How many wheels? Right? Makes sense, right? You're on track with this, and this just means term to me, right? Nomial means term in this context at least, all right? That's just the simplest way to think of it. Okay, and if you had 3 terms, let's say you had an x squared plus a 2x plus a 1, right? How many terms? 3. And what might you call it? So far, so good, right? Makes sense at least, trinomial. Now, what if you had more than one term, so you have 2 or 3 or 4 terms? What word could you use?
Poly.
Yep, you can use poly. Poly just means more than one, so we'll use the word, if it's more than this, we'll call it a polynomial. All right, and that's kind of your basic naming. What else can we talk about? We can talk about the degree of the polynomial. The degree is normally the largest power. So if this goes up to power 2, this would be called the degree. All right, is the largest power of the statement. All right, so that's some basics. Now let's go back and go through for exponents 3, we multiplied binomials. So here's 2 binomials. X plus 2 times, let's do an x minus 2. Let's do an interesting one. The signs change between them. What was the method we did last time? Anybody remember? FOIL. Okay, strange. It's all strange, right? F-O-I-L. First, these get multiplied. Outside, these get multiplied. Inside would be these 2 terms. And last would be these 2 terms. How many multiplication steps? 1, 2, 3, 4. It produces a quadratic. All right, quad being 4, and 4 multiplication steps is the way I remember it. If we do multiply this, you get x times x. What would that be? It's x times x. x to the power 2. Okay, good. X to the power 2. Outside, negative 2 times x is a negative 2x. Inside is a positive 2 times an x, so plus 2x. Last would be this one here, these two terms in the last section of it. So positive 2 times a negative 2 is a negative 4. Interestingly enough, what's our phrase for combining like terms? CLT. Everybody say CLT. Okay, good, good, good. And if you have a negative 2x and you add to it a 2x, what happens? Cancel out. Yep, trust yourself. They cancel out. They're gone. And so what's left? The x squared and the minus 4. All right, so we teach this as a FOIL method. And I kind of mentioned before that my students that come from other countries sometimes will say, what is this FOIL method? They say, why don't you just distribute it, right? Use the distributive property. And that's kind of a more standardized way of doing it globally, right? From my experiences in math. It's not complete experience, but that's some of it. So let's take a polynomial and multiply them. And I don't know if I can see this very well. Does this say 6d plus 4 there?
Yeah.
Okay. So I'm having a hard time seeing the board. 6d plus 4. This is one of the reasons I always use x's and y's. Do you see what my d starts to look like other things, right? So I apologize for that a little bit. I like to use x's instead of this. In fact, I might switch. 4d squared plus d plus 1. And I'm tempted to get rid of this variable. And let's change it out for an x. Because my d's are going to start to look like other things. There. So let's talk about the distributive property. Since we have two terms in this one, right? This one's a binomial, and we have three terms in this one. This is a trinomial, and we're going to multiply these together. What ends up happening is this series of multiplication steps. The 6x has to be multiplied by each of these three terms. 1, 2, and 3. See that there? At the same time, this value also has to be multiplied by all three terms. Starting to get a little bit complicated here, right? We've jumped up from FOIL at 4 multiplication steps. We've now got 2 terms times 3 terms. So we're going to have 1, 2, 3, 4, 5, 6 multiplication steps. So we're going to try to separate this a little bit to help our brain. We're going to take the first one times all 3 steps, which looks like this. 6x times everything in this parentheses. 4x squared plus x plus 1. And then we're going to take the 4, we're going to combine with this, we're going to add to this the 4 times all of them. So 4 times this whole thing. We're going to multiply first, and then we're going to CLT. Then we're going to combine like terms, right? So first we'll multiply. The multiply steps up here will be the 3 that we've already mapped out. The next will be these 3 that we've already mapped out. Only we'll end up doing them separately. And then we're going to combine them all together here for a combined statement, and then we'll combine like terms in that statement, right? So it starts out being a simple idea of multiplying polynomials. It starts to get a little complicated. You can imagine if there was a third term here, how many multiplication steps would it be? So you had 2 terms times 3, right? You have 6 steps. What if you ended up having a third term here? How many multiplication steps would you have? 9, yeah, would be. It just keeps going out there, right? And so it's expanding kind of geometrically, right? Our complication is getting increasing rapidly. So let's go ahead and start doing this. 6x times 4x squared is a 24x cubed. Good. 6x times x. Good. Nice. Thank you. Thank you. 6x times 1.
right?
Yep, don't, 1 times 6x, keep everything in there, right? Nice, okay, thank you. So now let's do this one. 4 times 4x squared. 4 times x. 4 times 1. Good. Now, these two have to be added together, all right? So, and keep an eye on me, because this is, as I'm copying things over, I'll start to just drop stuff out randomly, right? That's the way my brain gets distracted or whatever. Nice. How's that look? That looks pretty good. Okay, now we go to CLT, combine like terms. Here's a cubic term. So raised to the power 3. Are there any other cubic terms in this statement here? No. So that one's done. It has to stand alone. So bring it down first. 24x cubed. Are there any power 2s? These two. So we're going to combine these two terms. So now we're adding instead of multiplying, right? So first we multiplied. That's your brain doing one thing. Now our brain's switching. So if it's 6x squared, you're adding that to 16x squared. That would be, correct me if I'm wrong, 24x squared, right? 6 plus 16, 24. Whoop, 22. Thank you, guys. Thank you. Nice. Let's see. And 6x here plus 4x plus 10x. And the 4 comes down. It stands alone, only one of those. And there's our statement. So now how many terms we've got in that? Right? How many terms in your statement now? You're up to 4 terms in there, right? Yeah. We don't really say quadnomial, but I wouldn't be wrong if you said it, right? You can just start adding numbers. Or we would just call it at this point a polynomial, right? Or we could call it a 4-term polynomial, and its degree, highest degree, is now up to power 3. All right, let's see what the next example is. So I think the next example is more of the same, and so I might just go ahead and stop this now and let you work on some of these on your own. The key to the process is separating these out, and so what we're doing is the distribution property is being applied with all the terms in the one statement times all the terms in the second statement as we multiply it. Then you're going through the combined like terms and bringing those together, and we're done, okay? Okay, good.